Principal Sheep. Welcome back to our classroom. Today I will be teaching you about atomic structure and the periodic table. Today's contents contains what atomic number and mass number is, isotopes, the arrangement of electrons, and measuring atoms, the patterns of elements, the modern day periodic table, questions and answers, and a summary. An atomic number is number of protons that is in a nucleus of an atom. An atomic number is shown as Z. So if you see Z in your test, then just remember that it means atomic number. It is a unique feature for every element. Every element has a distinct atomic number, and no two elements so far that have been discovered have the same atomic number. The atomic numbers are found on the periodic table above the element symbol, usually. Sometimes it's on the side though. But if the periodic table is a bit confusing, just remember the atomic number is the number out of the two that is the smallest. In a neutral atom, the number of protons is the same number as the number of electrons. A mass number is a little bit different. A mass number is a total of protons and neutrons in the nucleus of the atom. It is a whole number and can't be found on the periodic table. To find the number of neutrons, just subtract the atomic number from the mass number, A minus Z, and that's your number of neutrons. The mass number is shown as A. So in your test, if you see the letter A, then just remember that it means the mass number. Isotopes of an element have the same atomic number, but different mass numbers because of the varying numbers of neutrons. An isotope is atom of the same element that have the same amount of protons, but different numbers of neutrons. They have the same atomic number, but different mass numbers. And the isotopes of an element have very similar chemical properties, but could have different physical properties. I will give you a few examples. There's two types of carbon. Carbon-12 and carbon-14 are the two isotopes of carbon. Carbon-12 has 6 protons and 6 neutrons. Carbon-14 has 6 protons and 8 neutrons. Hydrogen has 3 isotopes: protium, deuterium, and tritium. Protium has 1 neutron, deuterium has 2 neutrons, and tritium has 3 neutrons. Radioactive isotopes can be used in carbon dating, medical imaging, and cancer treatment. Stable isotopes are used in geological studies and environmental research. The electron configuration describes how electrons are arranged in the electron shells or energy levels of an atom. Electrons fill the lowest energy levels first, following the Aufbau principle. So if you take away one electron from the smallest energy level, then an electron from the next energy level will replace it. The electron configuration determines an atom's chemical properties and reactivity. What are electron shells though? Electrons occupy specific energy levels, also called shells, that are around a nucleus. Each shell can hold a maximum number of electrons. 2 in the first shell, 8 in the second, 8 in the third, 16 in the fourth, 16 in the fifth, and 32 in the sixth, and so on. The outermost shell, called the valence shell, contains valence electrons, which are involved in the chemical bonding that specific atom can do. A relative atomic mass is the average mass of an atom of an element, comparing to a twelfth of the mass of a carbon-12 atom. It is a weighted average of all the masses of an isotope of an element, taking into account their relative abundances. The relative atomic mass is found on the periodic table. The relative formula mass is the sum of all the relative atomic masses of all the atoms in a chemical formula. It is used for ionic compounds and covalent molecules. There are a few trends in the periodic table. The periodic table exhibits trends in properties such as atomic size, ionization energy, electronegativity, and metallic character. These trends are due to the arrangement of electrons and the increasing number of protons in the nucleus. In the periodic table, you don't say rows and columns, you say groups and periods. Elements in the same group, the vertical column, have similar chemical properties because they have the same number of valence electrons. Elements in the same period, horizontal rows, have increasing numbers of protons and electrons, leading to gradual changes in properties. Reactivity. The reactivity of elements is related to their electronic configurations. Alkali metals, group 1, are very reactive because they only have 1 electron in their outermost shell, and since it's only 1, they can lose it very easily. The halogens, group 7, are also very reactive because they can easily gain 1 electron since they have 7 electrons in their valence shell. Noble gases, which is group 8, are unreactive because they have a full valence shell and have no need another electron. The periodic table is organized by increasing atomic number. Elements are arranged in groups, in periods based on their electronic configurations, and chemical properties. Metals, nonmetals, and metalloids. Metals are located on the left side of the periodic table and have properties such as conductivity, malleability, and ductility. Nonmetals are located on the right side and have properties such as poor conductivity and brittleness. Metalloids have properties of both metals and nonmetals and are located along a zigzag line that looks like a staircase. The periodic table is very significant and is an essential tool for chemists, providing a systematic way to organize and understand the properties of elements. It allows scientists to predict the behavior of elements and their compounds. I'll give you a few questions based on the things we have learned today. What is the atomic number, which is Z, and what does it identify? Explain the difference between atomic numbers and mass numbers. What are isotopes? Give one example. How are electrons arranged in an atom? What is the periodic table, and how is it organized? The answer to question 1 is the atomic number, which is Z, is the number of protons in the nucleus of an atom. It uniquely identifies an element. This is correct because every element has a distinct atomic number, and it is found above the element symbol on the periodic table. The answer to number 2 is the atomic number is the number of protons, while the mass number is the total of protons and neutrons in the nucleus of an atom. This is because to find the number of neutrons, we need to subtract an atomic number from the mass number, so they must be different. Since if they were the same, if you subtracted the atomic number from the mass number, it would equal 0. The answer to number 3 is isotopes are atoms of the same elements with the same number of protons but different numbers of neutrons. An example is carbon-12 and carbon-14. Isotopes have the same atomic number but different mass numbers. The answer to question 4 is electrons are arranged in electron shells or energy levels around the nucleus. They fill the lowest energy levels first. This is because the outermost shell, called the valence shell, contains valence electrons which are involved in chemical bonding. The answer to question 5 is the periodic table is a table of elements organized via increasing atomic number. Elements are arranged in groups and periods based on their electronic configurations and chemical properties. The explanation is, it is an essential tool for chemists to understand the properties of elements. I'll move on to the summary of today's lesson. Atomic structure basics. Every atom consists of protons, neutrons, and electrons, except for hydrogen. Hydrogen only has 1 neutron and 0 protons. The atomic number, Z, defines the element and equals the mass of protons. The mass number, A, is the sum of protons and neutrons. Isotopes are atoms of the same element but with different numbers of neutrons. The electronic configuration means electrons are arranged in shells and orbitals around the nucleus. Electronic configuration determines an atom's chemical properties. Valence electrons in the outermost shell are involved in chemical bonding. You measure atoms with a relative atomic mass, AR, average mass of an element's isotopes. A relative formula mass is the sum of the relative atomic masses of atoms in a chemical formula. The trends in the periodic table organizes elements by increasing the atomic number. Elements in the same group have similar chemical properties because they have the same amount of electrons. Trends in atomic size, ionization energy, and electronegativity and reactivity are observed across periods and groups. Elements are classified as either metals, nonmetals, or metalloids. Metals are on the left side, metals are on the right side, and metalloids are just in between them. The periodic table helps predict element behavior and compound formation. And that is it for today's video. If you learned something new, please like and subscribe. 3, 2, 1.